Yeah, so testing didn't work out so well, and I found something embarrassing. So this load puts about 2 amps, and yeah, that happens. And that's not good. Okay, so now I know what this problem is. I'll just try to demonstrate it without any problems here. Okay. So get rid of this. And you might hear I'm a bit worried I shouldn't be doing this because there's a thunderstorm going on outside. Normally I would have everything unplugged. So if we go AC volts, okay. So the first question is the transformer not able to supply the current? So it's currently, no, that's not right. Millivolts AC, why is that not working? 18 volts. So does it drop? Not much. Not anywhere near the output. So the output drops. Okay. So why is this happening? I can hear the wind whistling. So the hint, which worries me, I'm thinking that I knew certain things. So on the old power supply I used one of these, this capacitor. And the new one's got much smaller capacitors. So if I get the oscilloscope on, I'm going to do this. Yeah. The thunderstorm, okay. If I can arrange this without, I'm going to do this. I need to get these. Hope you can see everything I'm trying to do here. Okay. So just need to do, I'm trying to do this in a very small spot. Okay, so if I get this, I want the DC output. Can that be DC output from the diode bridge without shorting anything? Okay. So that should be good for the oscilloscope because that's floating. So there's going to be no weird currents. So I want this. Okay. And you can't see anything. What we do is hopefully get the oscilloscope in the view of the thing. And not really. We're good? Oh, that's not good. Is that moving? That's not tightened down, that's why. Okay. So I'm using cameras that are all manual, so you have to bear with me. Because they're cheaper. How's that? That's not good. Why is that not good? Oh man. That ain't good at all. Just want to get it so that it's bit better. It's pouring now. Okay. So that's on the bridge. So if I do this, short, yeah. So you still see the voltage drop on the. Can I show this? Make sure the cameras are all pointing in the same direction. Yeah. And the reason is that the capacitors that I've used, embarrassingly enough, aren't sufficient. So what I can try, perhaps, will this work? Can I just poke these in here? Very dodgy. Holy shit. Okay. That was a decent whack. Does this work? Not bad. Not great. Okay. So with this big capacitor, reduces the ripple and I get a better. So that means that I need more capacitance than this. Oh, come on. Can I show the ripple? No, I can't easily. Can I? Yes, I can. Just a sec. I gotta get another. I'm scared something's gonna short and I'm gonna blow something up. I just need to put the headphones on so I can hear. No, what I need to do is oscilloscope probes. Multimeter probes into the oscilloscope, and they won't work because they're annoying. Okay. So we've got it shorted, and we've got the capacitor connected in a very dodgy manner, and it's outputting. It's not great. So what I want to do is look at the voltage. This could be very nasty. And I'll plug this one. The blue is going to be negative. Okay. Probably can't see. So if I hold this, negative. So the ripple's much reduced. So if I take this capacitor out, we'll get a drop. Can that be? Why's my hand in the way? Yeah, ripple. No ripple. And and good. But so 8,000 microfarads is better, but not enough. So I drop this. Shouldn't. Yeah. Yeah. So if I take the load out, yeah, it's good. So the capacitor is necessary. So what are we getting? Whoa. Whoops. Okay. Okay. So if I the AC couple And then, so measuring the, whoops, the ripple is what? What? That's just ridiculous. Is that right? Oh yeah. Fucking hell. That scares me. That's a pretty big ripple. So if I take this off, it almost goes to nothing. So it's still not great. Because when I use the other power supply, so 19.3. So we need yeah. Is that right? No, it's not. Peak to peak. How do I... analyze... I'm going to remember how to use the oscilloscope. I think the amplitude is doing something. 10 volts. It is 20... What's going on here? Ah, because the probe is in times 10. It's 1 to 1. 2 volts. Okay. That's better. So we got 2.5 volts of ripple. And that means, okay, what does that mean? That means that, whoa, why did my computer just make a beep? Are we still recording? Yeah. So the voltage, so what I want to know, oh, that is the volt. I am on the, I didn't even use the oscilloscope. What am I doing? DC coupled, and then, whoa. So now, where's, okay. I think I'm just gonna. So that's what. So that's 2, 5, 10, 15, 20. So it's, yeah. So the ripple. What do we need to get? Yeah, it's still, it's so it's only just at the verge of the cutoff of the regulator. That's what's the problem is that, yeah, it's a low dropout regulator. It's getting hot, but let me focus this a bit better. That's all. What am I thinking? The ripple. What's the maximum voltage? 5, 10, 15, 20, 22. Yeah, it's only just on the verge of. So if I take this out, what happens? Yeah. Now we've got. Why doesn't it tell me? I've forgotten how to work it. That's embarrassing. Cursors. Y cursor. Where's the control of the cursor there? And then cursor. Be good if I knew how to use it. And this one. There. Whoa, why is it not going there? 23.8. So I chuck this thing back on. And then change my cursor. The minimum is 19.18. Can that be seen? No. 19.18. Okay, that's not high enough, because if we want a, what's the maximum? 22, I forget the dropout. So if we're getting, we want maximum voltage about 22.1, and this the max. So to get that, no load. I need a better transformer. I think I don't want to use one. I mean, it's gonna work. It's gonna work. That's 23 volts. So 23 volts. I'll have to find out what the dropout. I can't remember what the dropout is. But on the fairly light load, because I think this is. It then drops to. Oh shit. Minimum of 19.43. Yeah. So 8,000 microfarads. We're getting 19.3 out. And what? 19.43. Whoops. No, that's not what I want to do. It is that, isn't it? That's not right. What is that? That's a trigger. What am I doing? So this, let me pull this again. It drops to the minimum. That's where the lower cursor is. So 19.5, say. And then the top of the ripple is 21.68. I can't do it when I'm talking, or imagining I'm talking to someone. I need to sit down quiet. This is so simple. I used to know about this stuff, and I thought I did, and I've completely forgotten about. I'd forgotten about what the point of having a large capacitor. But now I've got to try to fit two of them. I'm just looking. It's possible. But this is 75 volts, which is I only need about 30. So I take this off and get 20. Oh, about 20. There we go. 23.6, 23.768. No load from output of bridge. Yeah. We got all the numbers. Loaded. So 23.68, and that gives me 22.1. 23.68, 22.1. 22.1. 1.58. So it's on the verge. I may have to restrict. It's not the end of the world. Annoying. Okay. Oh shit, that's hot. Well, the power supply, my bit of the circuitry, just apart from the capacitors. Damn. I've got to fit them in that box. Okay. So, from my thoughts this was going to be a simple project, I'm now finding out all the things that I possibly knew once and have just meantime forgotten. It's a long time since I've made a power supply like this. So I've simulated in LTspice. And started measuring. So I've measured the transformer. So it's what did I say? 55.1 volts peak to peak from each winding, output winding, and when in Spice, so it's 27.5, 50 hertz, and these diodes are roughly in the ballpark. I can't find the bridge in LTspice. And this is the capacitor. So if there's a 1K load on the power supply, the ripple is pretty small. But if we put a 9.4 ohm, the test load on, and simulate again, yeah, that's why it doesn't work properly. The ripple's terrible. So I tried adding a capacitor that I had that's what's shown in the video, and I measured that to be about 8,300 microfarads. So if I add that in, okay, and then simulate, that's better. Well, that doesn't. So the lowest voltage here is what? Where is that? 23 volts, which means, so I was seeing the regulator output about maximum 19, and the dropout's 1.5, so 23.1. 21.6 should have worked, but the thing is, then I measured I started thinking about what could possibly get reducing this voltage, and I realized there's the resistance of the secondary transformer winding, and I measured that. So we put a resistor in here. What's the shortcut for placing a wire? I don't know. Should be a standard. So it's 3, I think it was 3 ohms. So now if I re-simulate it, whoa, what the, that's the input. Why is it showing me the input? Don't do that. This thing is free, but it's weird. That's better. No, that's not right. Why are we showing the input? I don't know. So I remeasured it. So this resistor, the resistance of the secondary transformer windings is about 0.3 ohms. And if you re-simulate that, then the minimum is 21.29. So that's 1.5, 19.79. So that's about the maximum I was getting. So this now is probably roughly correct. So adding that 8,300 microfarad capacitor. That's this simulation now agrees with what I saw, or what we saw. But the other thing I've realized is that whoops, if I click on this, we get up to 8 amps peak current in that big capacitor and some current in the other one up to about half an amp. I looked and it's rated, the small one's rated. However, if you take this away and re-simulate it, you get, so the small capacitor would fail, I think. It would boil because it's getting up to peak. I don't know how this would, eventually it would fail, I think, because it's, yeah, that's not right. It's massively underrated. So the fix is just to add some capacitance. So if I added, for instance, 10,000 and resimulate, then we get a pretty good capacitor up to 8 amps. The minimum voltage. Oh no, it's still the diminishing returns. So that transformer's slightly is insufficient to get me 22 volts. But it doesn't matter. So I just have to, I can't trust the regulator working when I'm at 2 amps when I'm at the maximum voltage. But if I change this to double or an 8 and then resimulate, then yeah, then it's what, 1 amp. Can we do it? 23 volts minimum. Yeah. Yes, it would work. So at 1 amp, it's fine. So maybe I can say that the power supply will work it'll work to the maximum output voltage at 1 amp, which is okay. Anyway, well, I've learned something, or I've relearned something, and it's good to use the simulator because it just helps with a lot of things. So if I check the diode current, which is interesting. So when it's starting up, so you change the simulation command, which I don't know where that is, to go closer to, oops, how do I do this? To stop it, 0.1 sec, wait a minute, I need how many, 50 hertz, you need a cycle, what's that? 0.02, so 0.1 second, but can give me some cycles. So that should now, whoa, yeah, okay. So the diode, the inrush diode current in one is there going to be another one? Same. Whoa, what the? That's a lot. I mean, I've used the bridges are 25 amps. I think they have, I think the diode bridge has, I think the spec of the diode bridge is the maximum inrush current. I think it's that one. I may have vowed to myself not to buy things from JK. So the peak forward surge current is 400 amps. So we're good. But I guess that would be required. I mean, there's a bucket load of things I had forgotten. Turns out nothing's simple. That's good. So the bridge is sufficient. I think the bridges are sufficient. So that one's, let me try that again. It's interesting, to me at least. An hour. That's how long it takes to ramp up. So this diode's got up to 18 amps, but these diodes. Whoa! Why is this one? It's one of the. It's interesting. Huh. Yeah. Interesting. And then this one. Okay, I think. I have to think about that. So this is wrong. And should be about and a lot larger. That's the circuit. I think everything else is okay. I'm wondering if these diodes that I've used are underrated, or what's the peak surge current of a 1N 4004. Just a random one. Let's have a look. Peak forward surge current. So when they're discharged, so 40 amps. Okay. Maybe that's okay. But yeah. Okay. Possibly I should have used bigger ones. Because you'd never know. I probably need to simulate the whole circuit and do some more tests, I think, if it matters. I'm not going to do too much high current work. I just wanted to give myself the option if I needed it, so it wouldn't happen. And the regulator doesn't the data sheets for the regulator I'm using, they say it doesn't matter too much about those having those diodes in it, but I'd still want to make sure I'm not doing something stupid. 40 amps. So look back at the circuit again. Okay, so it's going back to the. So it's everything's discharged. What's the failure mode? I mean, it ends up going back through. I don't know where it goes because it can't go back through the bridge, I don't think. I have to think about it. Anyway, so there's a bit more work to do and more procrastination, so more avoidance of doing what I was actually supposed to be doing, well, from my point of view. Anyway, thanks for watching.